Hi and welcome to Bytes and Bits. This is the second video in the snake tutorial. In the first video I was really taking you through the game and the various issues that you'll need to tackle, and that was an idea to get you set up to program the code yourself. But if you didn't manage that, or if you need some extra hints, well then this video I'm going to take you through my solution and we'll go through all the blocks of code and how they work, and how I solve the various issues with the grid system and food and all those parts. As I said in the previous video, this project is really a cut down version of the main project from my new Python course. So if you fancy learning how to program in Python and getting through the basics and all the way through to object-oriented code, then please have a check in the description below, where you'll get all links to that and also to the pages where you can download the source code and TIC80 files for this TIC80 version. So let's get started and have a look at the code. The code for the snake program uses all the same techniques covered in both the Space Invaders and Asteroid courses. So again, both of those courses are full tutorials in how to code, so they will teach you all these techniques. And this particular one going through now, I'm really just going to talk you through things, but assume that if you want to learn how to do it, you'll cover one of those other courses. So to begin with, at the top of our listing, we have all of our game constants and variables described. Okay, so various states here. We have the snake itself and its values, and then the body of the snake and the food. Going down then, we have our tick function, which covers the game's state control. Again, we'll be talking about all these in more detail when I finish this overview. So we have our start game state, initialization state, and our end game state, which basically put messages on the screen and then wait for you to press the Z button to start. And then we have our main play game state, and you can see that's just simply a series of calls to various functions which handle the various parts of the game. So we have a function which will draw the outline, which draws the green box around the playing area, a function which draws the scoreboard at the top of the one which checks for your key presses and then lets the snake move, the hunger bar, which is a timer for how long you have before you hit the next piece of food. We then check for collisions, and that will check for collisions with the wall and with other bits of food and the snake colliding with its own body. And then we draw the snake, we handle the food, which handles the timing of the food appearing on the screen and disappearing off the screen, and then we draw the food on the screen. So that simply is our main control loop while we're playing. It simply goes through that, doing all those functions, and that is the actual game. And then underneath that, of course, we have these actual functions defined out, where we will then control the snake and the various objects that make up our game, such as the snake itself, its body, and the food. Okay, so that's a quick overview of where we are with this code. And you can see as I flick through this, all of the code here, if you've been through either the Space Invaders or the Asteroids project, all of this will look very familiar. So let's start breaking this code down to see how it actually works. The main crux of how it works is based around the display and how the snake actually moves. So if I actually run the code and press Z, if we watch how the snake moves, you'll see that it is not a smooth animation. What it's actually doing is it's moving in little blocks, and these blocks are 4 by 4 pixels. So that gives us a grid on which the snake moves, and that's also a grid on which the food and everything else is drawn. Back in our code, we'll start with having a look at this play area then. So our TIC80 screen is 240 pixels wide by 136 pixels tall. So if we divide that by 4 pixels, that gives us 60 blocks across and 34 blocks down. And the way we're going to draw the board is we're going to have, if we start at the left-hand edge, so that is block position 0. Remember, we usually start at 0 when we're numbering things in computers. So block position 0 is actually going to be a margin down the left-hand edge. So our first active grid position is block number 1. And we can see there that we have our board X minimum value. So the minimum active value that our snake can take is block position 1. Going off to the right hand edge then, so we go from 0 to 59, which gives us our 60 blocks. So grid position 59 is the right hand edge, which is going to be a margin, which gives us 58 being the maximum X value that the snake can take, again using this grid coordinates of these 4x4 pixel blocks. Then in our Y direction, so again we're going to go from 0 is the very top grid position. So 0 and 1 are where we're going to put our scoreboard. Position 2 is going to be our border, which will contain the green line, which means then that block number 3 is going to be the minimum value that the Y coordinate of our snake can take. So going down to the bottom, so again we're going from 0 to 33, which gives us our 34 grids. So the very bottom grid, number 33, is going to be our margin, which means then that 32 is going to be the maximum Y position for our snake. So that defines the active play area in this new grid coordinate, so not pixel coordinates, in our grid coordinates, and again each grid square being a 4x4 pixel block. So if we come down, what we can do to see this working, we're going to skip over the game states and the start and so on. We're going to get down to the actual playing game state. So here we have our play game state. Well, what I can do here is I can start to block out some of the code from working. So if I just use the ---- sign, that will comment those out. And all I'm going to do now is I'm just going to allow the bit of code that draws the outline to run. So if I run that code and press Z, we now have the active play area outlined by this yellowy green line. So if I come back into my code, and we'll see that draw outline then is the function which does that. And all it's doing there is we're taking our 4x4 grid. We know that we have one grid block at the the left-hand edge, which means that we need to draw our line 3 pixels in. So remember 0, 1, 2, pixel 3 is the edge of that first block. And that's all we're doing here with the rest of these numbers. So that is the XY coordinate of the top left corner of our drawing. And then we're drawing across to the top right hand corner, and we're drawing it in color 14. Okay, so all we're doing really is we're taking these these grid dimensions and drawing a box around the edge of that border. Okay, and that gives us, if I come back down here, that gives us these 4 lines. And again, if I run that, we now have our grid being drawn, our outline of our active grid area being drawn. We then need to draw our scoreboard. So our scoreboard is drawn up on the very top of the screen. So we are printing out score, and then we have a global variable called score, which is going to be used to add up the score as we move the snake around. And that's drawn in the very top left-hand corner. So again, if I've got both of those going, if we do Control R, we can see we now have our score being added up into that top corner. So we've really got an area now, and the rest of our game will now happen inside this active play area. The next block of code to work through then is the snake itself. So if we have a look at the definition for the snake, so again we're up at the top of the code here where we've defined all of our constants and so on. But we also define our global variable, which is going to represent our snake. And we're using one of our Lua tables here to really sort of mimic an object. The TIC80 version of Lua does allow you to create a sort of real objects, but I'm only using them here to encapsulate the data representation of the snake. I'm not putting any methods in there. And again, if none of that means anything to you, obviously the Python language handles full object-oriented programming. So do have a look at my course on that. Or if you have a look at the Space Invaders and Asteroids courses, you'll see how we're using this Lua table to encapsulate the data that represents a snake. But really what we're doing is we're using these curly braces then. So our snake object is going to have a body, and that body is going to be an array of body segments. So each body segment is one 4x4 pixel, which makes up the snake's body. So again, we're going to have a head, that little red head object moving around, and then a number of green body squares, each being one segment. And each of those body pieces will be in this body array. The direction the snake's moving in then, we need to store that within the snake. And again, I'm using a number of constants. So I'm in effect what we call enumerating these directions. So in fact, I'm assigning a number value to represent each of the directions. So you can see here that the up direction is 0, down, left, and right. And that just lets me use these words so I don't have to remember what the numbers are. I can just use one of these constants. Okay. So the snake, of course, will have a speed, and the idea here is as the snake gets longer, this speed will start to increase. We have something called a grow counter. So as the snake eats a piece of food, it will need to grow in a certain length. And then we have this thing called hunger. So as the snake moves, our hunger counter increases, and if it reaches up to a maximum value, which we say here, the snake maximum hunger is 99, that's when you die. And that's the little bar in the top right of the screen. So that's defining our snake then. So we have snake object itself, a body, which is an array of body parts, and then these particular data attributes, which will be used to control the snake itself. So at the moment, our snake here is just being initialized, so it doesn't contain any information. The body itself is empty. So let's have a look at see how that gets initialized. So we know that our TIC function is really going to be checking on this idea of game state. So remember, our game has a number of states as we're playing it. So the first state it comes into is this game start state. And again, I'm using various constants here to define them. So instead of using numbers, we can actually have a meaningful sentence here. And each of the different game states will run a different little game loop depending on what needs to happen. So our start game state, if we have a look down here, it's just simply waiting for us to press the start button, and then it will go off and actually initialize the game, which is what we need to look at. But you can see here that depending on what our game state is, we will run different game loops. Some of these game loops only execute one time before moving on to the next one, as in our Init Game one. But again, you can see how we're controlling how the game state occurs. So our start game state then, basically if we press the start button, we jump to game state init. If we're in game state init, we will call the Init Game function, and that's where we're now going to set up all the variables. So this init function is called either at the very start when we went on our very first game, or when we are resetting our game after we have died. Okay, so this will need to clear out everything. So our score is set to 0. Our snake body is cleared out, so there could be some body parts left over from our last game. So we just simply clear that all out. And then we reinitialize our snake. So our snake really has a head and then the rest of the body parts. the head itself it needs to be in the first element. So remember, with a Lua array, that is element number 1. So it needs to be in the first element of our Lua table. So we've cleared the table out, and then the first thing we insert is our head. And the position where we spawn our snake, we store again that. We're using a couple of constant values up the top of the code there so that we can easily adjust that. So our snake spawn position X, we're going to spawn the snake's head at 1 block to the side of that, and I'll describe why that is in a second. And all we're doing then is our each body part is simply going to be a little Lua table which contains an X and a Y coordinate. And again, these X and Y coordinates are in our snake grid position coordinates rather than pixel coordinates. So remember, going from our 1 to 58 and 3 to 32, I think it was. So we create that little Lua table and we insert it into the snake body. That will be inserted in position number 1, the first element of our array, and that becomes the head. We then need to insert the body. So we can adjust the initial length of the snake using this constant. So again, that's defined up in the top of the code as well. And we're going to use a little loop here. So it's going to loop through. So body part is going to be our loop counter, and it's going to loop from 1 up to this value -1. Remember, -1 because we have already added the snake's head in. And I'm simply going to do this loop. And the loop it's going to do is it's going to create a body part at the snake spawn position. And it's going to insert that into the snake body. So again, these will now be position element number 2, 3, 4, and so on. And the reason we insert the head in a different position to the body is part of the snake's collision detection is that the head is in the same grid square as one of its body parts. So if we actually spawn the snake with its head on top of its body parts, then obviously we'll instantly die, and that's not what we want. So that's really why we're spawning the head 1 grid position to the right of the rest of the body. And for the rest of the body then, it doesn't matter, we're spawning them all at the same grid position, but we'll see in the code later on, as the snake moves, it will be a chain effect, so each body part will follow the body part in front of it. And that'll make more sense when we come to that bit of code. But at this point here, we now have a head and a number of body parts following it. And again, the number of those body parts defined by our initial snake length. So if we come up to our game loop, or down to our game loop, sorry, so which is here. Okay, so we now want to draw our snake. So let's come down here and let's uncomment that. So again, we are going to draw the outline, draw the scoreboard. We're not going to move or do any collision detection. We just simply want to draw the snake out. So let's play that and see what we've got. So you can see there we have our snake head, and then to the left of that we then have the other snake body parts. So there's actually a number of body parts sitting in there. As our snake moves then, what will happen is our snake head will, in this instance, because we're traveling to the right, it will move to this grid square here. The second body part will then move to where the snake head was. The third body part will move to where the second body part was. The fourth body part will move to where the third body part was, and so on. And that way, what we actually do is, in effect, as the head moves, every piece after it then follows it along. And as the snake head moves in a certain path, then obviously all the body parts will follow along that same path, because they're simply following one body part ahead of themselves. So the second body part will always follow the head, the third body part will always follow the second body part. So that's how the snake movement happens. So let's go back into our code and see how we actually do that then. So that's actually done in this function here called moveSnake. So if we come down to move snake, so let me just search for that. So move snake. Okay, so the actual movement of the snake then, it is run on a timed basis. So if I run the code, you'll see that the snake itself, it doesn't move at full speed. What it's doing, come out of that, is if we ran at full speed, remember full speed is 60 game loops per second, so 60 grid squares per second, it would take it well 1 second to get right the way across the screen, and that is really just too fast. So what we're actually doing here is the snake speed control is not so much how many blocks we move per loop, but it's how long we wait between each body movement. And that's what this snake move counter thing is doing. And if we look at our initialization code up here, so we have our initialization code. So we have our snake direction. So initially we're going to the right. Our snake speed is set as our snake start speed. And we then have this thing called a snake move counter. And what happens there is the value for that is set to the snake speed, and it then counts down. When it hits 0, that's when the snake moves. So the snake speed value is larger values are a longer delay and therefore a slower snake speed. So come down to our move snake one then. Okay, so we can see here, all we're doing is if I drop down to a smaller font size, we're decrementing our move counter, and if the move counter becomes less than or equal to 0, then we're actually doing a movement. So we reset the snake counter. So again, that's all that line there is doing, is resetting it back up to its initial speed. And then we actually do the movement. So this block of code here is moving all the snake body parts. Okay, so we're saying for body part, and we're going to take it from the end of the snake. So remember our snake.body is a Lua table that controls all the body parts. So hash, let me go back into bigger font size. So hash snake body gives us the last element in our snake body array. If you think about how we move this then, if we were to say the second body part moves to where the head is, then the third body part would move to where the second body part is. But of course we've just moved the second body part, so we'd end up having everything being in the same position as the head. So what we need to do is we need to actually do the movements from the tail end towards the head. So the last element is moved to where the second last element is. Then we can move the second last element to where the third last element is, and so on, right the way up until the second element moves to where the snake head is. So that's what we're doing here. So we're going to go from the tail of the snake to the second body element. So we're not going to do the head in this one. Because we're counting from a larger number to a smaller number, we have to use the step parameter in our for loop. So we're going to be counting down. So remember, every time we go through the loop, we add this number on to our index. So that will count us down. And in that, we're simply saying, so the body part denoted by our current counter. So remember this current counter here, setting its x value equal to the body part in front of it, so our loop counter -1, so that will give us the body part in front of the one we're currently looking at, its x position and its y position. So that will move each individual body part along by one segment. We then have to look at our head. Okay, so that's the whole body moved. We then move the head, and this movement of the head then is dependent upon our snake direction value. So if our snake direction value is up, then our snake body element 1, remember element 1 is the first position, which is the head, then we will decrement its Y value. Let me just go to a smaller font size. So we move its body up, else if its direction is down, then we increment its Y position, and left we decrement its X position, and right we increment its Y position. So that will move the head in the correct direction. So that's the code that actually moves the snake. But each time the snake moves, there are certain events that take place. So we have this thing called a health timer, and the idea here is that you have to eat another piece of food within a certain amount of time, otherwise your snake dies of hunger. So we have this thing called snake.hunger that you will have seen in the snake object definition. So each time we move, we increment that value. And really what we're saying here is if the snake's hunger value is larger than the snake max hunger value, and I think that was set to 99 up the top. So again, that's just lets us use this constant value here by name rather than by number. So, but if our hunger increases beyond this maximum value, then we simply signal that the snake has died, and we signal death in the snake by setting the game state equal to end. So that goes to the end screen. We have another little bit of code up here then. So really what we're doing is we want to have an audio feedback on this. So again, the snake counter up in the top corner will draw a bar, and that will eventually go orange and then red as the hunger increases. But once it gets up to a certain value, so once it's more than 75, then we'll actually have a little sound alarm going off. And that sound alarm then will just simply use one of these sound effects commands. So it's going to use sound effect 0. So that's in here. So sound effect number 0 is that one there. And if I just play that, you can see that just gives us a little bit of a ping. And the idea here is that the pitch of that ping will gradually increase. So we're basically doing snake hunger minus 40. So remember, snake hunger is going to increase from 0 up to 99. So this ping counter will start at 75. So snake hunger minus 40, so we'll start at 35 and increase up to 59. Up to that. So it'll gradually get a higher and higher pitch in little pings, which will sort of add that little bit of urgency that you have to eat some food. So that's the code that runs when it's time for the snake to move. The actual move snake function does have a number of other things happening inside it, but those are to do with the food. So we'll come back to those later. Really, the next thing we need to do is we need to make sure that our snake, we can actually make it move in certain directions. And that is done, if we go back up to our code, that is done with the check keys function up here. So if we look at check keys, really that's looking at the various movement buttons. So buttons 0, 1, 2 and 3, there are our up, down, left and right buttons. But what we're doing, as well as just checking if the button has been pressed, we're actually checking what direction the snake was moving in. So the idea here is that if the snake is moving in a certain direction, so say in this case here, say it was moving in the down direction, then if you press the up button, we don't really want it going back on itself, because of course that's instant death. So we're going to help the player by not letting them go back on themselves immediately. So really what we're doing here is we're saying, so if the up button is pressed and the snake's direction does not equal down, then we can set the snake's direction to be up. So, and else if we press the down button and the snake's direction is not up, then we're allowed to go down. And so on. So at this point here, we will press a key and we will signal to the snake what the direction of the next step is. Remember, our movement happens on that timed basis. So we're sitting in here monitoring key presses, As the player presses keys, we will set the next desired direction, and that will then not allow him to go back on himself. Okay, so after this check keys function, then this value snake.direction, remember that's a data attribute inside our snake object, that will have the next direction for the next step. So if we now run at that point, so again I've re-enabled the check keys method, function inside our play loop. So if we run, we should now have the game being able to control. And again, I can't go back on myself in this situation. So that's our snake now moving around. As we saw in the code, part of that moving around function handled our hunger bar. So we do have a function here which draws that hunger bar for us. And if we go down to that, so draw a hunger bar, we know that our hunger goes from 0 to 99. So what we're doing here is we're going to draw a rectangle which is going to be between 0 and 99 pixels long. So our snake.hunger actually gives us the pixel length of this bar. And again, this is now screen pixel coordinates. We're not drawing these in our snake grid coordinates. And really what we want, we've got 3 sections to the bar. So up to 50 is our green section. Between 50 and 75 is our amber section or orange section, and then above 75 is our red section. So really what we're doing here is we're saying, so we know that our green section goes all the way up to 50. So if our current hunger value is greater than 50, then we have to draw a full green section. Otherwise, we're just going to draw the green section up to the current snake hunger value. Same then for the 75, so if we are above 75, then we have to draw the full orange area for 75. Otherwise, we will just draw the orange area that is up to the snake hunger. So remember, so the size of our orange bar will be snake hunger minus 50. So the first 50 is the green, the next block is the orange. Then if our snake hunger is above 75, then we just simply draw a red section, which is the correct length. So remember, it'll be snake hunger minus 75. So remember, so at that point we will have drawn a full green bar, a full orange bar, and we then just simply draw the remaining bit in red, and that will give us our hunger bar at the top. Okay, so again, just a little bit of logic there to make sure we draw the correct bar with the correct coloured segments. And if we run that, you should see then that appearing up in the top right corner. And there is our hunger bar, and as the snake moves, you can see it gradually increasing. And as we get towards the end, eventually, as we get into our orange section, and then in our red section, we will get our audible feedback. Okay, and let's come out of that. Okay, so again, once I get to 99, we saw there that our snake dies. So now that we have our snake moving around and getting hungry, we should really add some food. So let's have a look and see how that takes place. So if we go up to our very top of our code, right up here, we'll see that we have a number of global variables which are going to contain the variables and models for our food. So we have a food array here. So this is going to hold, so each individual piece of food will be a food object, and they will be stored in this array called food. We set a maximum number of pieces of food that can appear on the screen at any time. And then we have a number of variables which will control the maximum and minimum amount of time that a piece of food stays on the screen. So again, this is going to be in game loops and ticks, so 60 ticks per second, so that's between 10 seconds and 3 seconds. The maximum food growth then, so that's going to be the number of body segments that this piece of food will add onto the snake. And then we're going to have a number of little sprites, which are going to be the actual food objects. So our system is going to randomly choose one of those sprites. So we have to tell it where the base number sprite is and how many they are. So if we go into this little sprite editor here, you'll see here that we have in that space there, so that is sprite number 16, and that's the first of our sprites, and there are 5 food sprites. So our system is going to randomly choose one of those sprites to be this particular piece of food. So that sets up the data around that. And again, if you're not familiar with how TIC80 works with sprites and so on, then do have a go through on the either Space Invaders or Asteroids course, and you'll see exactly how all this fits together. So let's come down then and see what happens. So obviously when we initialize our game, we initialize our snake body, our snake direction, and then we will also then make sure that our food array or our food table has got nothing in it. So we reset the food table to have no food. And at that point our game's going to start. So if we come down here into our playing state, so we know that we have this method here which it says HandleFood, and that obviously then is going to do the code to make the food appear and stay on the screen for the right amount of time. So that's the next function that we're going to have a look at. So let's come down and find HandleFood then. So our HandleFood method function. So there's a few things going on in here. The first block of it is to do with the timing out. So whenever food appears on the screen, it stays there for a certain time and then disappears. But I'll come back to that in a second. But the first thing I want to do is obviously to get some food on the screen. So we have a test. So this is our test to see if it is time to generate a new piece of food. So the first test we do is to check how many pieces of food are currently on the screen. So remember, hash followed by an array variable or a table variable will tell us how many elements are in that table. So if that's less than the maximum number of food items allowed, and then we're going to pick a random number. And this is how we create a random delay between pieces of food. There's a number of ways in which we can do this. One is to set a timer up, and we then would perhaps set that timer to be a random value each time we generate a piece of food. So our system will wait for that timer to time out before it generates the next piece of food. Or we're doing it in a way here, which was very similar to the way in our Space Invaders program where we worked out whether a Space Invader should fire a missile or not. And really what we're doing is every time we go through our game loop, we're going to execute this piece of code. So we are now saying here, we're going to pick a random number between 0 and 179. So we're going to choose 180 possibilities. And if it's less than or equal to 4, so we now have a 4 out of 180 chance of getting this value. Okay, so in other words, we're choosing a random number between 0 and 179, and if it's less than or equal to 4, then we're going to say it's time to spawn some food. So that basically means then that if we put 4 into 180, that will give us 45. And that's what we have, a 1 in 45 chance of spawning food. We're doing 60 ticks per second, so we should have food appearing every just under a second. Okay. And again, we can play with these numbers. If it's too many coming in, then we can obviously make that chance smaller, and the food will then appear at longer intervals. But if it's time to generate food, then we're going to create a food object. So we want it to appear at a random position on the screen. And again, we are using the snake grid coordinate system here. So remember, we defined these constants which will define the maximum and minimum sizes for our active play area. So we're really just saying choose a random number between board X min and board X max. Same for our Y value between board Y min and board Y ax. The food time is going to be how long that food's going to stay on screen. So it's a random number between this minimum value and maximum value. Remember, those were set up in our global namespace at the top, where we defined a number of constants. We give it a growth value, so between 1 and the maximum growth value. And then we choose a sprite for it. So it's going to be between 0 and 5. And then from that we can build up an actual piece of food object. So we're inserting into our food tables. Remember, so food holds as an array which holds all the individual pieces of food. So we give it an X and Y attributes. Timer then is the food time, that's how long it stays on the screen. Growth tells us how many body segments it's going to add in, and then sprite is going to be which individual sprite it's going to use. So we create that little food object and insert that into our food array. So our HandleFood function creates food and destroys food. We of course then need a DrawFood function to actually put it on the screen. So again, we're using this for in I pairs loop, and again that will then loop through every individual element in our food array. And for that then we simply draw a sprite. So the sprite number we use is the base sprite number plus this particular food object's sprite number. So remember, that gives us a 16 as a base plus that number we picked. And then we have to convert the X and Y coordinates of our food object from snake body grids into real pixel ones. And that's just simply, we know that our snake grid is simply 4x4 blocks. We just simply multiply each value by 4, and that will put our piece of food in the correct place. We then need to put a 0 after that. So if you look at the sprite command, if you go to documentation, you'll find we have sprite number, X coordinate, Y coordinate, and then something called a color index. And what that does, that tells us we can set a color in our sprite to be transparent. So if one sprite happens to overlap with another, then if we go and have a look at sprites here. So we can say this particular sprite, there's a lot of area here which is not used. So if we were to have a different sprite sat in this 4x4 block, then if this sprite came on top of it, if we set the black color to be transparent, then we'll still be able to see the sprite sitting in here. Okay, so that's what that extra little number there is. But that will then draw the food. So if we come back up to our TIC function, if I could spell. So, and again up in here, so we're going to our play game. So we've now got our DrawFood function in place. So we should be able to run our game and have food appear and disappear. So we had that little red piece of food there appear, and there it disappears. And we should now find that the other ones appear on screen at random intervals and then disappear after a while as well. And we have obviously our hunger bar going there. Okay, so we've now got the food appearing. So our snake can move, our snake can be under control, we can draw food on the screen. So all we need to do now is to be able to eat that food. And that's going to be handled in our CheckCollision function. So let's just uncomment that and have a look at what that does. So coming down the screen then, let's find our CheckCollision. So hunger bar, and here we have CheckCollision. Okay, so there's a number of collisions that we need to detect. The first one then is the snake actually hitting the edges of the screen. So if we come in here, we see that our snake body, so our head, is the only one that does the actual moving. So every time we move the snake, we just simply need to check where its head is. So if the head has gone less than the minimum X value, more than the X maximum value, less than the minimum Y value, or more than the max value, at that point our snake has actually collided with the wall. And at that point, again, all we simply do is we make the game state equal to game state end, and that will signify that the snake has died. We also need to check then if the snake has collided with its body. So that's got a bit more code to it. So we've taken that out to its own function. So we've got a new function called CheckBodyCollision. And if I just go to a smaller font size, oh, there's a smaller font size, sorry. So that function then, it needs to know where the head is. So if we come across here, we can see that we're passing in the head's X and Y coordinates. And then that will then send us back an answer, which will be true if the snake's head has collided with the body, or false if it hasn't. Okay, so if we get back a true value, we will then kill the snake. So let's have a look at what CheckBodyCollision does. So we come down here. So there's CheckBodyCollision. So it receives an X and Y coordinate. And what it's going to do, it's going to look inside the snake's body. So remember, snake.body is an array or a table that holds individual body segments. So we're going to loop from the tail of the snake up to its second segment. Okay, so remember the first segment is the head. So we obviously don't want to check if the head is in the same position as the head, because that would just always return back true. So we're just checking from body position 2 to the end of the snake. And of course, because we're going from the end of the snake to the head, we need to then step in increments of -1. So for each body part then, so if this body part we're looking at, if its X and Y coordinates are both the same as the head values passed in the parameters, then we have a hit. So our system will just simply go through here. The first time we get the head on top of one of the body parts, we return back true. If our loop gets to the very end, so we've checked every single body part and we still haven't found one, then we return back false. So that gives us then our body collision check. And then the last check we need to do is if we've hit a piece of food. So we're simply then going to say, okay, this new function, so we're going to create a function called CheckFoodCollision. Again, we're giving it the snake head position coordinates. And that's going to return us back a set of data, which is going to be collected in this variable called food piece. And really what that's going to do is send us back the copy of the piece of food that we have just hit. So let's have a look at that CheckFoodCollision function to see how that works. So here we go. So CheckFoodCollision, and so it accepts in our X and Y coordinates, which are the snake head position. We're then doing this for in I pairs loop, looping through each individual element in our food array. So that will pick out individual pieces of food. We then look at our food piece. So if our piece of food's X and Y coordinates are the same as the head position coordinates, then we simply return back the index of this piece of food in the food array. So that's what this is sending back here. Otherwise, it's going to return back 0. In other words, there's no food at all. Okay, so back up here then. So food piece is going to get the array index of this particular piece of food. If it's not equal to 0, then we have had a piece of food sent back. Remember, if we don't find any pieces of food, we send back 0. So we're simply then going to say, so in our food array, the element with index food piece, remember that's the value that comes back from our CheckFoodCollision, that bit there then is the food object which we've just hit. So we simply say our snake grow counter, we simply add on this particular amount of growth. And then our score, we will simply increase our score by the value of this piece of food. We will then make a sound effect. So we have a sound effect which will vary in pitch according to how much, what the value of this piece of food was. Remember this growth value. And then we will take this piece of food out of the array, because again, we've just eaten it. So once we've logged it and eaten it, we can then take it out of the food array so it's no longer sitting there. And once we've eaten a piece of food, then that resets our hunger value back down to 0. Okay, so that's our collision detection. So we are checking walls, checking body, checking for food, and then eating food if we have it. Okay. And that then really is our game. So let's have a look at it playing. So let's go to Control R and press Z. And there we have then, so we have our food coming, our snake coming across. We will then eat a piece of food if we get there in time. We get our sound effect, and you can see that our snake is growing. And actually that's the last bit of code that we need to have a look at. So we can see here that as we eat pieces of food, if we ever get to any, oh, we missed that. Should we get this piece of food here? We can see that our snake is actually growing. So let's have a look and see how we grow the snake. So we know that when we eat a piece of food, we're simply adding some numbers onto this snake parameter, which is the grow counter. So let's have a look at our snake handling. So we need to go up to our move snake function. Right, so in our move snake function up here. Okay, so every time the snake moves, we check to see if it is growing. So if our snake grow counter is greater than 0, then we want to put an extra piece into our snake body. Right, so all we're doing here is we're saying that we want to create a new piece, a new Lua table. It has an X and Y coordinate. Remember, that's all our snake body parts have. And we will put it at the same position as the tail of the snake. So it doesn't need to go anywhere different. It just sits underneath the tail. And of course, as the tail then moves away, these bits of food and body will be pulled in behind them. So we come down here, we add a piece of food in, we then take one away from our grow counter because we've just grown that piece of snake. If our snake grow counter is less than 0, then we just reset it back to 0, and at that point we won't run this loop anymore. Okay, so every time we eat a piece of food, we simply add extra bits, extra numbers into this grow counter, and then as we come through this function each tick, we will simply then grow another segment onto our snake and then decrement our counter until we've then created the correct number of segments in our snake. And while we're here, we can just look at the very last piece of code that we need, which is the snake speed control. So really what we're doing here, we're saying the snake speed, remember that was the number of ticks in between each movement of the snake. So really what we're doing is we're saying here that we're going to have a look at the length of the snake. We're going to divide it by 20, and that's going to give us then a value. So as the snake gets larger, this number here will get larger as well. So we have an initial snake speed. So remember, our snake speed, the larger the value, the slower the snake moves. So really, we're taking our base speed, or our base delay rather, we're taking away this ever-increasing number, which is based on the snake body. And eventually that number will get, so the start value minus our new body dependent value will eventually come all the way down to 0. And of course this bit here just limits it to 0, so we don't get less than 0. And at that point our snake is going at full speed, and as the snake gets bigger and bigger, it never gets less than a delay of 0, so our snake is then moving at full speed. And that really then is the entire game. So if we have a look up here, again, we'll see then that we've now got all of our code in place. And if we run, we'll see that we have the full game functioning, where our snake grows, and as it grows, the speed of the snake will gradually get faster and faster until it gets up to its maximum speed. So the only thing we haven't covered yet are the various assets or the sounds and the graphics that go with the game. So if we come into our editor, and again, if we have a look in our sprite editor, really all we're doing there, as I said, everything's based on this 4x4 pixel grid. So we have there a sprite, which is the main body of the snake, and we then have different head positions for the snake. And again, as the snake's direction changes, we'll simply draw the head, the correct valued head sprite, which matches up with the direction of the snake. And then of course we've already seen then that our fruit or our food sprites, they're just simply a number of sprites there, and we log the base sprite on that. For the sounds in the system, if we come across, I've only really defined two of those. So the first sound then, that is used for the alarm as the hunger counter gets up towards 100%. And we see in the code that gradually increases in pitch. And then the second sound is just used then for the food being eaten in the game, and again that too then increases in pitch as the food gets larger in value. The very last bit of graphics we use for the system is in the very first start screen. So if I run the code, you'll see that we have this initial graphic comes up, and this is called a cover image on the TIC80, and really all it is a GIF file. So if I go across to a little paint program, so I've created a little GIF file, and that has to be a full size TIC80 screen. So that's 240 pixels wide and 136 pixels tall. So you simply create a GIF file to those dimensions. Then when you come into TIC80, if we come out to our main console, so I've got the game loaded in. If I then import a cover image, it will then go and ask me which cover image I want to import. So it will bring up my file dialog on my computer, which is here. And again, I then simply go and find my cover image, which again was that one there. And when I open that, I'll not just reload that in. And when I open that, then as I run my code, that image will be shown as soon as the code starts running, and will stay on screen until we then change the screen display. So that's why if we come back into our code, and again remember we go to the start game, so initially our game comes in here and we run the start game loop. You can see here that it doesn't include any clear screen. It doesn't affect the screen display at all. It just simply sits waiting for a button press. So that means that our initial cover image will stay on screen until we then press the fire button and then go off into the actual game. So that's really everything then for programming this snake game. So I hope you've gone through that and understood what's going on. As I say, I haven't tried to teach you how to program it in this. I'm just really showing you how I got through all of the challenges in making this game work. If you want to learn, then please do have a go at the Space Invaders, which is the very beginner's version of my tutorials, and which then leads into the Asteroids game, which is a slightly more complex game, but again using all of the same techniques, but just a slightly more complex game to code. If you really get the bug for coding, then please do have a think about taking up my Python course. Again, I'll leave all links for all of these things in the description down below, but please do have a think about doing that, where we can then get into a fully fledged programming language, which you can then take way beyond this gaming environment and off into a professional career if that's what you're looking for. So please do have a look at that, and really just have fun writing code, writing games, and just enjoying the whole process. So, see you soon. Bye for now. Don't forget to visit the course pages for this project. There you'll be able to download the code for this lesson and get lots of extra hints and tips. You'll also get access to all my other programming, electronics and gaming projects. All the links are in the description below. For more games programming, electronics projects and retro gaming, please make sure you like this video, subscribe to my YouTube channel and visit my website.